Hello everybody, welcome to this video. In this session we will dive into the Medallion architecture in Databricks with a special focus on the silo layer, which is the transformational layer. And our goal today is to walk through the process of transforming raw data into refined structure and valuable insight the insights that can be used for analysis and reporting. We will be covering complex transformings and applying a range of functions like an aggregation function, a string, date and time, and more, and implement real business scenarios. Before we get started, let me give you a quick overview of Medallion architecture. This architecture is typically divided into three layers. Bronze is about raw data and unrefined data, and silver, cleaned, transform, and enriched data ready for further analysis, and finally gold layer related to create data used for reporting or machine learning models. In this video, we will focusing on silver layer of transformation, where we will use advanced function to prepare data for downstream analysis. Imagine a scenario where we work with the e-commerce data. The data comes from various sources like customer transaction, product catalogs, and customer feedback, all stored in the bronze layer. In the silver layer, we need to transform this data into a structured format for analytics purpose. For example, we need to calculate total spent by each customer in the last 30 days. We will join customer data with transaction detail to find the highest revenue generating customers. Overall, we will clean the data by handling missing values and dates while using aggregation function to summarize the data. So we will also use window function to calculate running total or ranks of product, a string operations, and a condition function. We will let's classify product into categories like a high or low revenue. Let's define a complex user-defined, semi-complex user-defined data set in Databricks. Here we simulate an e-commerce platform with the three tables: customer, transaction, and first data set is customer data, contain three columns: customer ID, customer name, and email, and two records. And next data set is transaction data. This transaction data contains 5 records and 3 columns: customer ID, transaction date, and amount spent. Customer data holds customer IDs, name, and emails, and transaction date records customer purchases, transaction dates, and amounts. Okay, first function, we combine the customer and transaction data set using inner join on customer ID that is common customer between two data sets, and this ensures only matching records are included. Okay, you can see this record. Just recorded recorded returns to dataset that have common match customer ID into datasets. And next function is date and time function. Using date and time function, using the date and time functions, we will filter transaction from the last 30 days by calculating the difference between today's date and the transaction date. First of all, I import necessary libraries. Okay, we filtered transaction from the last 30 days by calculating difference between today's date and the transaction date. And next function is an aggregation function. We calculate total spending per customer using the sum aggregation function grouped by customer ID. Okay, so I calculate the total spending per customer using the sum function and grouped by customer ID. And you can see we have the three records: Alice, Bob, and Charlie. Okay, and calculate spending per customer. Yeah. And next is a null handling function. We handle missing values by replacing null in the total spent here. with a 0, ensuring data completeness. Okay, you can see replace 0, yeah, missing value, replacing null in the total spent with the 0. Here for Charlie. And next function is window function. Using window function, we rank customer based on their total spent in descending order. First of all, I import two libraries, PySpark SQL window and PySpark SQL function for window and rank. Here. Okay, let's break this code down step by step so you can clearly understand its functionality. First of all, I imported two libraries. Window this allows us to define a logical partition of our data for advanced operation like ranking or aggregation over subset data, and rank. Oh, sorry, it's rank here. A Spark function that assigns a unique rank to each row within a window based on a specified order. And here. And we define a window specification which determines how our ranking operation will work. Order by function sort the data in descending. Here, listen here. Descending order of the column total spent here. And This ensures that customers who spend the most are ranked at the top, provide valuable insight into our top spenders. Okay, and this code line, we use the with column method to add a new column called rank to our dataset here. And since the window is ordered by total spend in descending order, the customer with the highest spending get rank 1, and second highest get rank 2, and so on. This is generally useful for identifying top performing customers in a business context, or prioritizing segments for marketing campaigns. Okay, and here I want to show the result set. Okay, you can see rank column and total spend. Based on the total spend, this column get a rank, so from 1 to 3. Okay, the rank 1 has the highest value in top spend. And next function is string functions. We apply a string function to convert customer name to uppercase for consistency. Oh, I forgot import. Import the library. I import upper. Okay, I add a new column called upper customer name upper to rank customer dataset, and assign result to new dataset a string transfer. You can see change with the uppercase, upper function. Okay, and next function category is a conditional function. Here we categorize customer into spending tiers using a conditional function. Okay, and first of all, import library. Okay, customer are classified as here high spender spending greater than 500 and medium spender spending between 200 and 499 and low spender spending below 200. And here you can see here. And next function is the mathematical function. We run the total spend column to decimal places using a mathematical function to clarify. First of all, I import necessary libraries. Okay, here I define new column with the with column method and run, and here and we run the total spend column to decimal places using mathematical function for clarify. And here okay, sorry, we don't have a float data type here, so return as integer. And last function is a type conversion function. Finally, we convert the rounded spent amount to a string for downstream processing using type conversion. Okay, and here okay, it's converted to a string. Okay, and it's a final code. Okay, I combine all each of parts of code in a it's a unit code here. In this video, we demonstrated how Databricks transform raw data in the silver layer of Medallion Architecture, apply a wider range of functions using include, join, window function, and more. Deliver clean, enriched dataset for downstream analytics. By these techniques, you can create professional grade pipeline that enable actionable business insight. Thank you for watching. Don't forget to like, share, and subscribe for more data engineering content.